Okay, class, welcome back to this next lesson for today. Today, I'm going to teach you all something on chapter 3 or chapter 14, which is called electric current. And let's look what is the topic is about. Okay, today's topic will be 14.2 drift velocity. Okay, so before we look at this drift velocity, I've already taught you in the last lesson on what and how or is drift velocity exist in the metal in a conductor. Okay, metal or a conductor, my last lesson. So now we're going to look a bit more extra and deeper on this concept of drift velocity. Okay, so we're going to explain the concept of drift velocity and we're going to derive and use the equation, and the equation is I equals to venA. Alright, so let's look at the lesson now. Let's look at the next class, which is a drift velocity, which is the concept of learning outcome where we explain the concept of drift velocity, and we're also going to derive and use the equation for this lesson. Okay, so this was my previous class. Alright, so in the previous class I just want to let you all know this is the word off, yeah, because I spoke off but I wrote the word or. Okay, so this was the concept of how a drift velocity is formed. Okay, that how we understand a drift velocity concept inside a wire. Now let's look at these notes here. So before that, I have a cell which is connected to a switch and also connected to a resistor. Okay, now before the switch is closed, before that means the switch is open, the free electrons, okay, in metal are in constant random motion. Okay, so it's like this lah, like the previous class. I'm just going to take a part of this wire here. Okay, so this is the part of the wire. Okay, area is A, length is capital L. Okay, and they have these atoms, or we call it or positive ions. Okay, and then they have free electrons. Okay, so what happened here, the free electron in metal are in constant random motion. Number one, the mean velocity of the free electrons is 0. Okay, and number 3, the concept says that mean speed is of the order of magnitude 10 to the power of 6 ms negative 1. Okay, now what happens next is, when the switch is closed, this is the cell. Okay, the switch is closed. Okay, there's a resistance, and I take this part of this conductor. Alright, so we have all these atoms or positive ions, and then we have a free electrons. Okay, so here becomes a positive potential and here becomes a negative potential, higher and lower potential. What will happen is, exactly like the previous class, what will happen is the free electron will drift. The free electron will move in random motion
and at the same time drift towards the end of the positive potential. Okay, the drift of the free electrons, will constitute an electric current. Okay, so what is the drift velocity? The drift velocity is called as the mean velocity of the free electrons towards the positive potential. Okay, and the drift velocity symbol is V. Okay, and it is in the order of, V is usually in the order of magnitude 10 to the power of -5 ms -1 to 10 to the power of -4 ms -1. So this is called as drift velocity. So the definition or the meaning of drift velocity is the mean velocity of the free electron towards the positive potential, or we call it as positive potential lah. Okay, so this is what it's trying to say here. The free electrons in metals are in constant random motion. The mean velocity of the free electrons in random motion is 0. This is one keyword. Mean speed is second keyword for free electrons in metal. But when the potential difference is applied, you see the word potential difference is applied. Okay, the free electron will move. Free electron will move in random motion and at the same time drift towards the end of positive potential. The drift of the free electron in the wire constitute an electric current. Drift velocity is the mean velocity of the free electron towards the positive potential. Okay, so it's in the order of this. So this one we will look at this now under derivation of the equation I equals to, we call it venA. Okay, so I'm going to look at this. Yeah, alright, so this is the circuit. Again, I'm going to draw a circuit. This is the circuit which is to the resistance. Then there's a switch. Switch is closed. So I'm going to take a portion of the circuit here, which is a length of L. Okay, so the length of L, the wire will look something like this. Okay, this is the length of L. Area A. Okay, and then we have all those free electron and of course all the positive ions or the atom. But we are just going to focus on the free electrons since the drift is about the free electrons. Okay, we know that this will be a positive potential. Okay, here is positive potential, here is negative potential. So this is positive potential, this is negative potential. We also have some extra knowledge, which is what class? Which is there is an electric field from the positive to the negative potential, and of course there is also a force, which we are not going to look at this now. Okay, but I'm just telling you the concept there, because which I already teach you in the last class. Okay, so what happens here now? Okay, the number, first thing you have to know how to derive the equation. Number of free electrons per unit volume. Okay, symbol is small n. is number of free electrons per unit volume, is capital N over V. Okay? Alright. Number 2, volume. Okay? V is equals to A times L. Okay? Volume of this wire is A times L. Okay? Volume. Alright? Okay, now. Alright, so here we have Q equals to number of free electron in the length L of the wire. Okay, so number of free electrons, which is capital N, is equals to volume times with small n. Correct? Okay, and what is V? V is AL. So AL N, capital N. Okay, number 4. Alright, charge. Charge carried by free electron. Q equals to NE. And what is N? N is this. So we get ALNE. Alright? Okay. So now, another one. Number 5. Time taken for the free electron to move length L. Okay, we know the formula comes from V equals to S over T. Where's my pencil? Okay, V equals to S over T. Okay, I'm just going to write down here. We know V equals to S over T. S here is L, T is T, V is V. So T equals to L over V. Okay? Alright. So next, what happens? From the definition of current, okay, I equals to Q over T. And what is Q? Q is from here, which is A, L, and E. And what is T? T comes from number 5, L over V. So we get the formula I equals to A, V, and E, which we rearrange this and we can rearrange whichever you like, but I always rearrange this to become V, E, N, A, venA. V is velocity and V is drift velocity. Who is V? V is drift velocity. Who is N? Number of electrons per unit volume. A is area, E is the charge of electron, I is the current that flows in the wire. Okay, so this is the formula for the current or for the current in the circuit. Okay, so you need to derive, class, if you see here, you need to derive and use the equation. So I've shown you stage by stage, step by step. Okay, first thing, you get the number of free electrons per unit volume. Symbol is small n. Okay, over capital N over V. Okay, volume is area times width length. Number of free electrons from here, from number 3. Okay, and then you substitute number 2 inside here, and then you charge carried. Okay, charge carried, and then time taken for the free electron to move length L is L over V. Okay, and then definition of current you put in, and you get the answer, you get the equation I equals to venA. So the book says derive and use the equation. So I'm going to give you all the questions for you all to do now. Alright, so thank you class. Okay, before thank you, look at this, what the note says. The same thing that I've spoken, it has also spoken here. The important concept here is, first thing, the number of free electrons per unit volume is small n. Okay, and then you can see the number of free electron in a length, and then they get this. Okay, but I've already explained to you how they get that. Alright, and then after that, charge carried by these electrons, and then they use the definition of current, and then they use T equals to L over V. So they get the formula I equals to venA. Okay, why I use the word venA is because venA is actually a blood artery. Is it one of the blood artery? You ask the biologists, they will tell you what is the word venA stands for. Alright, okay, thank you class.